Hi, in this video, I will be showing you how to deploy RUCKUS Virtual SmartZone for Enterprise. We will be deploying two networks. The first is an 802.1x WPA2-Enterprise authenticated network for employees, and the second is a dynamic PSK network for guests. Here is the technology that I will be using in this video. I will be using a VMware ESXi server, and I will be hosting on that server a Ubuntu server as well as a RUCKUS Virtual SmartZone VM. I will be setting up FreeRADIUS on the Ubuntu server, and I will also be deploying RUCKUS R730 APs that will be connected to the virtual SmartZone. This is a network diagram of roughly what your network should look like. You should have a router that is connected to the internet, and I would recommend that you have a switch connected to your router. Connected to your switch, you should have an ESXi host, and on that host you should have two guests. One is the virtual SmartZone, and the other is the Ubuntu server. Also connected to your switch, you should have your access points, which you will be using to connect to your wireless clients. Now, you might be wondering, why are we going to use 802.1x authentication for the employee network? Well, that's because using a shared credential for all employees is generally a recipe for disaster. The PSK will eventually be leaked, and it can also be guessed. Once the password has been leaked or guessed, then anyone, including bad actors, can freely join the network. Changing the PSK after it's been leaked will kick all devices off, which makes it a pain to try to reconnect legitimate devices. 802.1x solves these problems by allowing for centralized control and per-user authentication. If one account is breached, then you can reset it without affecting anyone else's connection. When an employee leaves the company, then you can just disable that employee's credentials. Now, as for why we're going to use DPSK for the guest network, that's because an open SSID allows anyone, again including bad actors, to freely join the network. A captive portal on your SSID may prevent people from getting beyond the gateway, but we would prefer to keep bad actors off of the network entirely. A PSK-protected SSID has the same leakage issues that we mentioned previously, but DPSK solves these problems by allowing for each device to have a different PSK. DPSK allows for removal of a specific device by deleting its specific PSK. One DPSK does not affect any other DPSK, which means that when you delete one, it does not kick all of the other devices off the network. Before we can set up FreeRADIUS, or the WLANs for the employees and the guests, we must begin by setting up the two machines that we will be using. The first is a Ubuntu server. I will be installing this on VMware ESXi. To install this Ubuntu server, begin by searching on Google Ubuntu Server 22.04 LTS. Then click on the first link here that says Download Ubuntu Server. Next, click the button that says Download Ubuntu Server 22.04.2 LTS. Note that this version may change slightly, such as the 2 becoming a 3 in the future. Wait for the ISO to download. Once you have downloaded Ubuntu Server, it is now time to download the virtual SmartZone. You can do so by logging in to support.ruckuswireless.com. Click the Login button, and you should log in, and if you are prompted for your password, you will need to enter that. Next, use the search bar and type Virtual SmartZone. Then, scroll down and click the part that says vSZ Products. Scroll down until you see this. Click on the Downloads tab, then switch to Filter by your latest version. For me, it is currently 6.1, but it may be higher in the future. Next, scroll down until you see the file that says vSZ Software Release ESXi/AWS.OVA image. Click on this link. Next, press on the Download Software button. Scroll down, agree to the terms and conditions, and click Download. Wait for the vSZ OVA to download. Once the vSZ OVA is finished downloading, you may close these tabs. Go back to your ESXi console, and we will begin by creating the Ubuntu server VM. Begin by clicking Create/Register VM. Next, click Create a new virtual machine and click Next. Enter a name for the machine. I will be naming it FreeRADIUS Ubuntu Server. Select the Linux Guest OS family and scroll down to click Ubuntu Linux for the Guest OS version. Make sure that you click 64-bit. Next, choose where you want to store this virtual machine. The host that I am using only has one data store, so I will be placing my VM there. Next, configure the virtual hardware settings. I will be setting up my machine with 4 virtual CPUs, 8 GB of RAM, and 32 GB of storage. Next, I will set the data store ISO file so that we were able to install Ubuntu Server. Upload to the data store the ISO you have just downloaded. Once the ISO is downloaded, select the ISO you just uploaded. Then click Next, double check that everything you have selected is correct, and finish. Next, click on the virtual machine you just created and click Power On. If you click on this area right here, it should pull up the console, and you should see something like this. Click Enter to install Ubuntu Server. You should now see a section that asks what language. I am obviously going to be choosing English. You can choose to update to the new installer, but I will be continuing without updating in order to save some time. Next, you need to choose your keyboard configuration. I will be choosing English US. You will also need to choose Ubuntu Server for your type of installation. As for your network connection, I will be using DHCP, and skip these next 2 pages. Next, you will need to choose your storage configuration. I will be using the entire disk, and then you will need to confirm your new configuration and wipe the disk. Next, you will need to set up some information about your profile. I am going to be setting it up as myself. Obviously, you should change the information that you are going to be using here. I'm setting the server name as FreeRADIUS Ubuntu, but again, you can set this to whatever you would like. I will be setting my username and my password, and you will need to use this later to log into the Ubuntu server. Say no to Ubuntu Pro. Make sure you install the OpenSSH server. And you can skip installing other server snaps. Now we need to wait for Ubuntu to install. You might be here for a while. Note that when Ubuntu restarts, it may tell you that it failed to unmount the CD-ROM, in which case you will just need to hit Enter to reboot one more time. Next, you will need to log in to the Ubuntu server. I'm just obviously using the credentials that we input during the setup configuration earlier. And as you can now see, our Ubuntu server is now ready for us to install FreeRADIUS. Now we need to set up the virtual SmartZone. Go to Create/Register VM, and this time select Deploy a virtual machine from an OVF or OVA file. Then enter a name for your virtual machine. You can obviously set this to whatever you would like. Next, you will need to select the OVA that you downloaded earlier. Hit Next, and then again select the storage where you would like to store your virtual machine. You will need to accept the license agreement, and then click Next. You can leave it as thin disk provisioning because it is unlikely that the vSZ will need all 150 gigabytes it is assigned. Once you hit Finish, you will need to wait for the OVA to upload to the ESXi server. Once the virtual machine powers on for the first time, you will need to enter Actions, then Edit Settings, and make sure that you delete the second and third network adapters. The other interfaces are typically used in conjunction with a virtual SmartZone data plane, also known as a vSCD, which is a separate product from RUCKUS that requires a separate VM. Once you have edited the settings, we now need to reboot the vSC by right-clicking on the row, then going down to Guest OS, and clicking Restart. Once the vSC reboots, we're going to want to log into the vSC using the default administrative credentials, which are admin and password admin, all lowercase. Once the CLI loads, you're going to want to type setup. When prompted, you're going to want to select IPv4 support, and then I am going to select manual assignment of our IP addresses. However, you can choose to do DHCP. I'm going to be entering the address that I want this device to use, as well as the subnet mask. And then I'm going to be entering the gateway address, as well as the primary DNS address. You can leave the secondary DNS address empty. When prompted, say yes to apply the settings. The vSC will then prompt you to confirm the settings one more time. Say yes. Now we can use the web user interface to finish the setup process. Navigate to the IP address that you set in the network configuration, as well as navigating via HTTPS and port 8443. You may receive an SSL warning, however, you can ignore it. Upon loading the setup wizard, the virtual SmartZone will have to load the network settings that you have already configured. Once the network settings have been loaded, you can now enter your cluster information. This information is not relevant right now because I am doing a single vSZ installation. However, it is important if you are actually deploying a cluster. Once you are done, hit Next. Next, you will need to enter an administrative password for the web GUI as well as the CLI. Note that the wizard does have relatively strict password requirements in that you must have a password that is at least 8 in length with 1 letter, 1 number, and 1 special character. Here I have set the password to admin123!, which fulfills the requirements. Once you hit Next, confirm everything that you have set up on the final confirmation page. Then hit Finish. Now we need to wait for the vSC to finish its final configuration. This will take about 15 minutes. Once the vSZ has finished configuring, you will then see a link for you to click. Click that link. You can again ignore the SSL errors, and then it should show you the virtual SmartZone interface. When prompted, you should now enter the administrative credentials that you configured earlier. For me, this is admin and then admin123!. Once you log in, you will need to wait for the vSC console to load, as this is the first time that it is loading. Once you see this screen, you can now look at all of the dashboards that the vSZ has to offer. From here, if you want to onboard APs, you will need to plug them into the network, obviously keeping them on the same VLAN in subnet, but they should automatically adopt. To set up the employee network, which will be protected by 802.1x authentication, we will first install FreeRADIUS on a Ubuntu server. We will then configure FreeRADIUS to accept the Radius authentication requests from the virtual SmartZone. We will then configure user credentials on FreeRADIUS. We will then configure the virtual SmartZone to use the Ubuntu server as a AAA server. We will then create and configure the employee Wi-Fi network, which will include configuring 802.1x authentication as well as a VLAN tag for the network. First, we will begin by installing FreeRADIUS on a Ubuntu server for the 802.1x authentication. Run the command sudo apt install FreeRADIUS. Type in your password for your Linux machine, and when prompted, say yes. Wait for FreeRADIUS to install. Once FreeRADIUS is installed, confirm that FreeRADIUS was installed correctly by typing FreeRADIUS-V. You should see information about the version of FreeRADIUS that you installed. Next, double check that the base config of FreeRADIUS is valid by typing sudo freeradius -C_X. You should see at the bottom when it is done, configuration appears to be okay. Next, use any command line text editor to edit this file. I will be using VI. So I will type sudo vi/etsy/freeradius/3.0/clients.conf. You should see a file that looks like this. Scroll down until you find the area after the base config. Then insert a new line and type this. Client vSZ. In this case, vSZ is the name of the client. You can name this whatever you would like. Then open curly brace, go to a new line, hit tab, then type IP_adder space equals, and then the IP address of the client of the FreeRADIUS authenticator. In this case, it will be the vSZ, and since I have already deployed the vSZ, and I have defined a DHCP fixed host for it, I know that the IP address of the vSZ is 172.30.80.20. You will need to replace this with whatever IP address that you need. Next, you will set the shared secret. I will be setting the shared secret to super secret password, but obviously you should change this in the event of a production deployment to be something more secure. Then you will make another line and end curly brace. Then I will now save this file and quit. Next, I will VI into another file. This time it will be etsy freeradius 3.0/users. I will scroll down to the area where they normally contain some of the testing users. So in this case, since Bob is right here, I will be entering a new line after the Bob entry, which is currently commented, and I will type user, which is the username, and then to specify the login, I will say clear text -password equals open quote password. You will need to put whatever password that you want for the user in here. Then now I will save and exit. Next, what you will want to do is type sudo systemctl restart FreeRADIUS. This will restart FreeRADIUS, and should reload with the new configuration. Next, type if you want to make sure that FreeRADIUS is always started when the Ubuntu machine powers on, you will need to type sudo systemctl enable FreeRADIUS. Next, to check the status of FreeRADIUS, type sudo systemctl status FreeRADIUS. As you can see, FreeRADIUS is active and running, and there are no errors. Hit Q to return to the command line. In order to test the radius configuration that we have created, I will type rad test. This is the library for radius testing that is built in to FreeRADIUS. I will type rad test user. This is the username that we set earlier in the configuration. I will then type password. This is the password that we also set earlier. Then I will type 127.0.0.1 since we want to test the FreeRADIUS server that is on this machine. Next, I will type 0 because you do not need to care about this, but you can look this up in the rad test documentation if you would like. And next is the shared secret. In this case, because I am accessing the Radius server from the local machine, the shared secret will be different from what we set. It will be the base default configuration. The base default shared secret is testing 1, 2, 3. Then I will hit enter, and as you can see here, it has sent the radius access request, and we have received a radius access accept. Now we have a radius server that is set up to allow for 802.1x authentication. Next, log in to the virtual SmartZone that you have deployed on your ESXi server. Here you can see that I have already deployed one cluster, and there are 8 APs that are associated with this vSZ. First, go to Security, then find the Authentication section and click on Proxy SC Authenticator. Next, you will want to create an authentication service. You can name this whatever you would like. I will be naming it FreeRADIUS Server. Then you will want to make sure that the service protocol is set to Radius, and underneath primary server, you will want to enter the IP address of the Ubuntu machine on which you installed FreeRADIUS. In my case, this is 172.30.80.18. Leave this port as the default 1812. Next, you will type the shared secret, which we configured earlier in the FreeRADIUS configuration. For me, the shared secret is super secret password. Then confirm the secret by typing it again. For me, it is super secret password. Then click OK and wait. As you can see, we now have a FreeRADIUS server set up. Click Test AAA in order to test this. Given that we have just created the AAA server configuration in the SC, it says please wait 30 seconds. Once you have waited those 30 seconds, you should then click on the name of the server that you have just created, which in my case is FreeRADIUS server. Select a protocol. You can leave this as PAP. Then enter the username that we specified earlier in the FreeRADIUS configuration. For me, this is user. Then specify the password that we also specified in the FreeRADIUS configuration. For me, the password is password. Then click Test. If you have set up your FreeRADIUS and vSZ correctly, you should now see a dialog that says AAA testing success. Do not worry about the groups because we have not set up any. Next, click Cancel and go to create a new wireless LAN. Go to Network, Wireless, and click on Wireless LANs. Then, click on the zone with the access points that you would like to add a WLAN for. For me, this is the zone named HBR730 zone. I will click here and click Create to create a new WLAN. The new WLAN, in my case, because this is the employee network, will be called Employee. Leave the SSID or change it to whatever you would like. Next, go down to Authentication Options and click on the Method section 802.1x EAP. This should automatically configure the encryption option for WPA2. Leave that as is. Then scroll down to Authentication and Accounting Server. Turn on Use the controller as proxy. Then select an authentication service. In my case, I will select the FreeRADIUS Server authentication service we just created. Then, in order to access the VLAN that I have specified for this WLAN, I will scroll down to Advanced Options, Access VLAN, and change this to VLAN 400, which is the VLAN I have specified for my employee network. Then click OK. As you can see, we have now created the employee network with the employee SSID, 802.1x authentication, and on VLAN 400. Now, to show that the WLAN that we have created works, I have pulled up an iPhone. As you can see here, under the Wi-Fi networks, you can see the employee SSID that we just created. I will click on this SSID and I will log in using the credentials that we specified in the FreeRADIUS configuration earlier. For me, this is user with the password of password. I will then trust this certificate. And as you can see, we have connected. To configure the guest network, which will be protected via DPSK, we will first create and configure the guest wireless network, which will involve configuring DPSK authentication, as well as configuring a VLAN tag for the network. We will then create DPSKs for guest devices. Create a new network. Type in the name of your new WLAN, which for me will be guest. You can change the SSID if you would like. Next, scroll down to Encryption Options and click WPA2. Then go to the DPSK section and click Internal. You should also enter a passphrase, but you will not be using this passphrase, so you can use whatever you would like. Next, set the DPSK length that you would like to use, as well as the DPSK type and the DPSK expiration. For me, I will be setting the length to 10 and numbers only to allow me to type the DPSKs easily. Next, I will select for the DPSK expiration 1 day from first use. You can set these to whatever you need for your deployment. Next, scroll down to Advanced Options. Find the Access VLAN option and change the VLAN ID again. In this case, I have specified that VLAN 300 is for my guests, so I will change this number to 300. Then I will hit OK. Next, to generate your DPSKs, go to Security, find the Access Control section, and click on Dynamic PSK. Then, click on the zone that you have created your DPSK WLAN for. In my case, this is the HB R730 zone. Next, click Generate DPSKs. Select the WLAN that you would like to generate DPSKs for. In my case, this is the guest network. Next, specify the number of DPSKs you would like to generate. In this case, I will only be generating one DPSK. You may specify the name of the batch of the DPSKs you are generating, or you may leave it blank. You can also leave the VLAN ID field blank, as we have already specified the VLAN that the WLAN is configured for. Then click Generate. You can download a comma-separated values CSV file for the PSKs that were just created. Next, open the CSV file. As you can see here, we have created one DPSK. This is the DPSK we have created. To show that this DPSK works, I will now be connecting to the guest network using the PSK that we have created. As you can see in this list of Wi-Fi networks, I can see the guest SSID. I will click on that SSID and use the passphrase that we have just generated. Next, I will click Join. As you can see, we have successfully connected to the guest network using Dynamic PSK. As a bonus, I have also coded a Flask server in Python, which allows you to manage the users of your FreeRADIUS server. As you can see here, I have created a GitHub repository, link is in the description, which contains the files that you need to run this server. There are 3 files in this repository. The first is app.py. This Python file contains the code which runs the Flask server that provides the user management interface. The second file is the index.html file located inside the templates directory, which is used to provide the HTML that the Flask server renders as the web interface. The third file is a .service file, which is used by Ubuntu's systemctl to create a service that allows you to automatically start this Flask server whenever the Ubuntu machine boots up. First, confirm that the version of Python that you have is properly installed. You can confirm this by typing python 3 ---- version. Next, confirm that you have pip, Python's package manager, installed properly by typing pip3 ---- version. If pip is not installed properly, you can type sudo apt install python 3 -pip. As you can see, pip3 has now been installed properly. Next, you will need to install the Flask dependency using pip, because we will be running this Python server via sudo in order to access the restricted files in ESXi. We must type sudo pip3 install flask. Next, load the Flask server onto your machine. You can do this by going to the GitHub repository, opening the app.py file, and clicking copy. Go back to your terminal, then type cat greater than app.py. Hit enter, paste the file, hit enter one more time, then hit Control D. Next, we will need to move the index.html. Open the file and copy it from the repository. Go back to your terminal. In the same directory that you were in previously, create a new directory called templates. After creating this, make sure that the templates folder and the app.py are within the same directory. Otherwise, the app.py will be unable to find the index.html. Next, create the index.html file by typing cat greater than templates/index.html. Hit enter, paste the HTML file, hit enter one more time, and then hit Control D. If we check the templates folder, as you can now see, the index.html is now here. To run the Python Flask server, type the following command: sudo python3 app.py. As you can see, I can now access the Python server at the IP address 172.30.80.18, port 8888. However, if you would like to set up the server such that it will power on whenever the Ubuntu machine boots up, you may use the following steps. First, go back to the GitHub repository and find the FreeRADIUS flaskmanager.service file. Copy the contents of the file. Go back to your terminal and use your favorite text editor, mine is VI, to enter the following file. I will type sudo vi/etc/systemd/system. When I hit tab here, all of these files end in .once or .service. If you see this, you are in the correct place. Next, type the name of the file you would like to use. In this case, I would like to create a new file called FreeRADIUS flaskmanager.service. I enter the file, paste the contents of the service file, and then I save. As you can see here, this service executes this command. This command is executed as the root user, so we do not have to worry about permissions. However, you will need to change this path here to be the path to wherever you have placed the app.py file. I will now quit the file, and in order to enable systemd to recognize the new service that we have created, I will type the following: sudo systemctl daemon reload. Now, when I type sudo systemctl start FreeRADIUS Flask Manager service, it auto-completes because systemctl recognizes the new service. I will hit enter and also type sudo systemctl enable FreeRADIUS Flask Manager.service. The first command I typed, which starts the service, will only start the service while this Ubuntu machine is currently on. It will not restart the service when the Ubuntu machine reboots. However, the second command, the enable command, will enable the service to restart such that it will always turn on whenever the Ubuntu machine turns on. You can now check the status of the service by typing sudo systemctl status FreeRADIUS flaskmanager.service. As you can see, the Flask Manager is actively running, and again we see this debug information that tells us where the Flask server is running. To utilize the user management interface, navigate to whatever the Flask server tells you it can be accessed on. For me, this is 172.30.80.18, port 8888. I will be using Firefox for this demonstration. You should be brought to a page that looks like this. You should see at the top a table of the current usernames and passwords that are configured in the FreeRADIUS user settings. You have the option to delete any user in the table. You can also add a new user using this form and then clicking Add User. Once you are done changing the configuration, press this button here that says Save Configuration, and it will save the configuration to the disk.